So, Jai Hind everyone. In this video, we are going to see about the enzyme. And enzyme is what? Enzyme is very important because in NEET they will ask at least one question from this question, this topic. And if they will ask one question, it will carry around. It will boost your rank by 2,777 if 20 lakh students are going to sit in the NEET examination. So that is a big rank. 20,000, sorry, 2,000 rank is a good rank if you will increase by 2,000 rank. So what it is, enzyme was first discovered by A. Penn. Okay, A. Penn, who was he was the person who discovered this, the first enzyme. So what was the first enzyme which was discovered? That was the amylase. Hope so you know about the amylase because we already studied in the 9th 10th classes. If you don't know, don't it's not a big deal. I will tell you, amylase is just it will convert uh, carbohydrate into simplest form. Okay, like disaccharides and monosaccharide, it will convert. So amylase, it will digest the carbohydrate. That's it. So if you see the properties of the enzyme, the properties of the enzyme will be like this following. I am going to tell you about this. So these are enzymes are mostly protein, but some enzyme like ribosome have RNA. Okay, so mostly enzyme is made up of what? Protein. Second thing is what? If any reaction is occurring from A and B, or suppose simple only I am writing, A is converted into B product. So there will be rate constant, that is a K constant, and that K constant will be always same. So A is for A is forming P product, and that is a reaction is going on in 1 hour. Okay, suppose 1 hour. If you put an enzyme, without enzyme it is going for 1 hour, but if you put an enzyme, it may be finished within a 10 seconds. Okay, so once it was about 1 hour taking more time, when you put the enzyme, this is your enzyme. When you put this enzyme, then your reaction become very fast, but the K constant will be remain same. So we can say the equilibrium constant. Okay, the reaction equilibrium constant will be always same because if you put the enzyme, the product will be same and substrate will be also same. It won't become a B and P will not become a S. Got it? So it will be always A and P. So this is the concept. What we will write? We will write here. We will write that enzyme increase the rate of reaction. Enzyme will increase the rate of what? Reaction. Will it change the rate constant? No, never. Okay, the rate constant will be same. So what I will write? But equilibrium equilibrium will maintain, or equilibrium will be not changed. Okay. Third thing, if we take amylase, will this amylase will digest the lipid? No. Will this amylase digest the protein? No. What it will digest? It will digest the carbohydrate. So amylase is specific to what? Carbohydrate, not lipid. Got it? Not protein. So amylase are like that Proteins, enzymes are very specific. Enzymes are specific to specific to substrate. Enzymes are very specific to the substrate. We discussed it will increase the rate of reaction. So if we have to run, if you have to jump this much height, okay, if you I have to jump this much height, so I will require more energy to jump this much of height. But if I have to jump this much of height, so I will require less energy. Okay, so whenever we have to change the substrate into product, we want to decrease the requirement of energy. That is called activation energy. Activation energy is what? When the enzyme and substrate both will be bind, there is a change in the free energy. Okay, got it? So that energy is called as a activation, means something, the product is activated, sorry, the substrate is activated to convert into product. So that is called activation energy. So we will see this enzymes, this is a sign of decrease activation energy. Okay. Enzyme will decrease the activation energy, got it? Now we'll see the enzymes are classified into what? Enzymes are classified into 6 classes. So before going to the 6 classes, I will tell you the trick. What are the trick? Ox transfer to Hyderabad. Okay, Ox transfer Hyderabad, but liar is not. Liar is not liger or lion, you can say. Okay. So what does it mean? This is two sentence. Ox transfer to the Hyderabad. Simple. Liar means who lie is not liger. Liger. It's not a liger. So this is the meaning of note is not anything. It is just for accomplish the sentence. So ox means what? Oxidoreductase. Reductase. So oxidoreductase means which will promote the oxidation or reduction. Got it? Which will promote the oxidation of reduction, like dehydrogenase. Okay. So this is the first class. Second class is what? Second class is transferase. So what it will do? It will transfer the any group of a substrate from one substrate to the another substrate. Oxidoreductase, what it will do? It will oxidize or reduce any one substrate. Okay. So Hyderabad means hydrolase. Okay. In presence of water, hydrolase will break the bonds, break the substrate bonds. So that is called hydrolase. Hydrolase. Lyase means what? Lyase. So lyase is what it is doing. It will break. It is the fourth class. This is the fourth class. It will also break the bond between a substrate, but it will break a specific bond and without water. That is, the bonds are like carbon carbon, carbon nitrogen, carbon sulfur, carbon oxygen. Okay, that type of bond it will break. So lyre will what it will do? It will break the bonds, and this is what is means what isomerase. Isomer, you know. Okay, so it will make the isomerase like epimerase enzyme is there. Okay, so epimerase will make the isomer. So that is a isomerase enzyme. Liger means what? Ligase. That is the sixth one. And one more is there, which is not in the syllabus, but that is called as a translocase. And I'm not writing it here because it's not in the syllabus. So ligase, what it will do? It will ligate. Ligate means it will add two bonds. Okay, carbon, 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 nitrogen, like that. Okay, carbon, oxygen. So it will add the bonds. So what? Now we'll see the structure of the enzyme. Enzyme is having two components. I will try to finish it fast. Hope you understood. I'm going to erase it. Okay. Hmm. Now see, enzyme can be simple enzyme, okay, or it can be conjugated. It can be simple or it can be conjugated. Listen it properly, otherwise you will confuse because it is a little bit confusing. But I will try it. I will make you sure that you will be not confused after this lecture. So listen it properly. Simple enzyme is just a it have a protein. Nothing is there. Just a protein. Conjugated enzyme means what? Conjugated means what? In general words, conjugated means two things are mixing together. So in this you will see the enzyme, that is what? Protein, and plus that is called cofactor. Now this cofactor, once the protein will bind with the cofactor, then it will called as a holo enzyme. Only one protein, this one portion that is without cofactor, that is called as a apoenzyme. Okay, so you can write the enzyme minus cofactor is what? Apoenzyme. And apoenzyme is what? Inactive. Inactive. And holoenzyme is what? Active. Now this cofactor, if you will see, this cofactor, it can be metal or it can be any organic compound. Take understood. So if it is an organic compound and if it is a metal, there is a different name for the cofactor. Okay, got it. So the organic compound means what? It will call as a coenzyme. Okay, so it will form a, if it is an organic compound like vitamin B2, riboflavin is there. Okay, what it is? Riboflavin. So it is a cofactor of the enzyme dehydrogenase enzyme. Okay, it is a cofactor of a dehydrogenase enzyme like niacin. Niacin is also cofactor for the dehydrogenase enzyme. Where it will require dehydrogenase, you can say for the FAD or NAD. You see, the FAD and NAD will be reduced into NADH or FADH. In that, this dehydrogenase is required. In that, this riboflavin and niacin is required. So that is called organic. In metal requirement, like if you will say the kinase enzyme, okay, kinase enzyme, what it is required? Potassium. Okay, peroxidase, like iron it will require. So like that, the enzymes are there. But the binding of these cofactors can be tightly or it can be loosely. So if in case of metal, if it is a tight, if it is tight, so it will call metal activated enzyme. Okay, metal activated enzyme, or it will call, if it is a loose, if it is a metallo enzyme, you just change it here. Okay, loose and this tight. But the most of the questions they ask from this organic cofactor. So I think it is hidden here, but you listen me properly. I will show you in the last this hidden portion. Organic compound, if it is a tightly bond with the covalent or non-covalent bond, that is called prosthetic group. Prosthetic group. Okay, if it is bonded with tightly. Understood? So, if it is a loosely bound, then it is called co-substrate. This is the important question because they already ask this type of questions. The tightly bound or cofactor for the enzyme, that is called prosthetic group, and for loosely bound then it is called co-substrate. There you will heard one more term that is called coenzyme. If organic compound is bonded with the protein, that enzyme, then it is called coenzyme. That organic portion, non-proteinaceous portion, that is organic portion, that is called coenzyme. So hope so you understood these all topics, and I'm going to over this class here only. Thanks for watching. We'll meet in the next video. One more thing I am missing. If you have in doubt, then please go and like the videos and comment me in my uBiology app. It is showing in the line uBiology app. You can click your questions on the photo and then you can send in the uBiology. I will answer your questions for any subject. We have a faculty for physics, chemistry, and mathematics. You can click the photos and you can send it in the uBiology app. Thanks for watching. We'll meet in the next video. Jai Hind.